Hi, and welcome to ArcGIS Pro, Geoprocessing in Parallel using Apache Spark. I'm Sarah Ambrose, and I'm presenting with Bethany Scott. We're both product engineers on the GeoAnalytics team. We're going to start with a few questions to give you an idea if the GeoAnalytics product and toolbox is right for you. So have you ever failed, or have you ever had analysis fail because your data was too big? Or have you ever waited for a tool to finish and it took forever? These are the kind of questions that the GeoAnalytics toolbox hopes to answer. So what is GeoAnalytics? It's a toolbox that parallelizes computation to quickly analyze large amounts of vector and tabular data. So this isn't a product for raster data. This is purely your points, lines, polygons, and tabular data. And it's just a collection of analysis tools that are aimed to identify patterns, relationships, anomalies, and incidents in a large amount of data across both space and time. And the emphasis on time here is because usually with big data, you might have a timestamp of sorts. So it could be AIS data you've accumulated, it could be some other movement data. Time is not required, but a lot of our tools take into account time in addition to space. So how is this special toolbox faster than other toolboxes, or how is it able to parallelize our data or analysis? And we do that by using Apache Spark. So all of these tools have been written by our developers to use Apache Spark and distribute the analysis across the cores on your machine. Those are then exposed as tools, and we can talk about which tools those are later on, as a toolbox in ArcGIS Pro. So why would you use GeoAnalytics? One of the reasons is existing tools and workflows aren't processing data fast enough. Or maybe you need to distill your data into something more manageable to use in other analysis. Or maybe your data just has a ton of noise and you want to explore it to bring out what's important. So maybe you use a few GeoAnalytics tools to figure out, hey, that's the interesting part of my data. You extract that and you continue to use more tools that you would normally use in ArcGIS Pro. Or maybe you have data sets that you're struggling to load into your GIS. We're going to talk about something called big data connections, which help you load a collection of CSVs or delimited files or shapefiles as a single data set quickly and easily. And then also some of these tools are only available through GeoAnalytics. So even if you don't have huge data sets, even if you don't have time, some of these tools you might be just interested in using on your regular size data because some of them are really cool. So let's give an example of analysis that you can run. I have 3 examples here. Obviously, there are so many others as well, but these are just to give you an idea of the types of analysis we see. So which stationary pressure sensors in my pipe network have experienced anomalous events in the past 24 hours? And where are their hotspots of anomalous events? Another one is where have my delivery trucks traveled and where is the highest density of unique delivery truck paths? And where do these delivery trucks travel the slowest? And where and when are events happening close together in space and time? So how do you actually get these tools? These tools that are created in Spark and exposed as tools have 2 different products. So there's GeoAnalytics Server and there's GeoAnalytics Desktop. What we're talking about today is GeoAnalytics Desktop. So we have another presentation that I'm giving along with Noah Slocum on GeoAnalytics Server, which is using ArcGIS Enterprise to distribute the analysis across 1 or more machines. GeoAnalytics Desktop is parallel processing on the cores in your laptop or desktop where you run ArcGIS Pro. The requirements are that you have an advanced license at this time, but other than that, if you have Pro today and advanced license, you can go use these tools. So how do you know when to use desktop or when to use server? For GeoAnalytics Server, you might be wanting to use that instead of desktop when you bring your analysis to your entire organization. So because those tools are exposed through server, I could run them, but so could someone else in your organization, and you'd share the results as feature services. That's just the result output. They are feature services. You want to leverage the power of 1 or more server machines, so you can use 1 or 3 server machines. So maybe if your analysis, you were running it in GeoAnalytics tools in desktop, and you said, hey, it's running great on 1 machine, but I want to expand out to 3 machines, that's when you might use GeoAnalytics Server. If you want to connect to external big data storage and existing web layers, so they have something called a big data file share, which can let you connect to Hadoop, HDFS, Hive, and your cloud stores as well. Or if you want to extend custom analysis. So we have something called Run Python script, which lets you write your own Python script that calls Spark, and you can do your custom distributed analysis on your server. For GeoAnalytics Desktop tools, which this presentation is about, it's when you want to process local data, so from files or databases, faster than before on your own desktop machine, or when you want to prototype workflows to use with GeoAnalytics Server. So you can try a subset of the data, just try out the tools, and then decide, is GeoAnalytics Server right for you because you want to span out to 3 machines. And when you want to use big data connections. And we will talk about those, but that's a way to connect to your shapefiles and delimited files, and it's very similar to a big data file share in GeoAnalytics Server. I have this table here. I'm not going to go through all of it. There's a blog post covering it. It's really here for reference if you want to come back. And it talks about the different input data, output data, how you can scale out analysis, the number of tools, and the interface between GeoAnalytics Server and GeoAnalytics Desktop. It's almost kind of equal at this point. We're adding more tools all of the time. Currently, we have 22 tools in GeoAnalytics Desktop for Pro 2.7 and 28 tools for Enterprise 10.9. I'm just going to leave it there. You can look at it, but I would say this is kind of something you might want to come back to if you're deciding between the two. All right. So with that, Bethany is going to give us a demo of running a GeoAnalytics tool.
Thanks, Sarah. I'm going to be demonstrating the power of GeoAnalytics desktop tools by joining 125 million buildings to over 73,000 census tract areas across the United States. This is a big analysis, and it's going to happen right here on my laptop in a little under an hour. To do this, I'm going to browse to the GeoAnalytics Desktop Tools toolbox and select the Join Features tool. This tool is a popular first step in data exploration and visualization, especially when your dataset is as large and noisy as this one that you see here in my map. So this is an incredibly dense dataset that offers us little information in its raw form, but after using Join Features, we'll see this data as it relates to census tract locations. So all I'm going to do is select my census tract areas to join to, and my 125 million buildings as the join layer. I'm also going to select this new parameter called Keep All Target Features that was introduced to ArcGIS Pro 2.8. This allows me to maintain all of my census tract areas in the result, even if they aren't joined with any buildings. But before we take a look at the results, I'd like to show you this parallel processing factor. This parameter is offered in all GeoAnalytics desktop tools. You can find it under the Environments pane. So GeoAnalytics leverages Apache Spark to parallelize your analysis across all available resources on your desktop machine. This parameter allows you to control how many resources to allocate to the GeoAnalytics job. You can give a percentage or a number of cores that you want to use, which allows you more control over your desktop resources. All right, so I do have a result layer loaded here in my map. Immediately, the visualization improvements are obvious, and we have much more insight going forward in analysis. Quickly, I'm going to showcase the difference that using the Keep All Target Features, or left join, parameter made. So here you can see that we've maintained our over 73,000 features for census tract locations, even if they didn't have any buildings joined to them. By default, however, we would have lost those tract areas that didn't have any buildings within them. So now we've seen the ability that GeoAnalytics offers you to crunch through big, noisy data and turn it into something more meaningful for use in further analysis.
Thank you, Bethany. Joint features is one of the most powerful tools, and we'll talk about it a bit later, but a lot of the analytics and the powerful joins that you want to do with spatiotemporal and attribute joins are available through that tool. I want to give an analysis overview now to talk about what tools we have, as well as give some details on some of the most interesting tools that might be unique to GeoAnalytics. Here are all of the tools we have available. I believe on the earlier slide I said there were 22. I don't want to go through all of them. They're grouped into tool sets to help you make sense of what you can do with them, such as analyze patterns, use proximity, manage data, summarize data, find locations, and data enrichment. The three that I've highlighted in blue, trace proximity events, summarize center and dispersion, and calculate motion statistics, are all new tools at Pro 2.7. I'll be talking about two of those in a bit more detail in further slides. The analysis capabilities of GeoAnalytics allow you to work with data in both space and time. So you can use them to perform spatiotemporal analysis, and you define your temporal input data using instants, a single moment in time, and intervals, a duration in time. You can visualize these results using the time slider. I want to talk a bit about track analysis as something to focus on here. So track analysis is not required, but it's something that a lot of people use GeoAnalytics for. To start us off, I want to talk about what is a track. What are we talking about here? Most simply, it's measurements recorded over time. Often this is a moving vehicle or a moving object that may have been recorded with GPS, but it doesn't have to be. We use the sensor network, which could be in a single place and just recording measurements over time. That can be used in a lot of the tools as well. So I'm going to talk about a few of those tools just to give examples. So the first one is Reconstruct Tracks, which helps you visualize where tracks have gone using breadcrumbs as input. So on the left, you can see we just have a bunch of points, which doesn't really help us at all understanding what this data looks like. But then we can visualize it into tracks. These are actually hurricanes, and you can see where the hurricanes have traveled. You can also buffer them by some value. So I think here we're buffering them by wind speed. So you get a polygon layer that represents the strength of the hurricane as it travels. The next one is calculating a field, which allows you to calculate values and conditions based on previous or subsequent values in a track. So for example, we have our track here. I have a value at each one. So this is just a field on my input points. The first one is 1, 2, 2, 8, 12, just some random numbers. And then I'm able to create an arcade expression where it says the previous value plus the value in the future equals the current value. So for example, this first one, there's no value before, so it's just a null plus 2. So you get a value of 2. And you can see it continues like that. So 1 plus 2, the previous value and the future value. And it continues. So you can use these very powerful expressions that we have through Arcade using a history of a track, both forward and backwards, which allows you to do a lot of really interesting stuff. The next tool lets you find features that meet a specified condition. This one definitely doesn't have to be spatial. It could be a sensor values, and I think we actually have a demo somewhere about that, so I will try and link that as well. And this one's detect incidents. So within a bunch of data, you can find the features that meet a specific condition. And you can use those arcade expressions. So you could do something like find the values that are 2 times the mean of the previous values. The next one is find dwell locations. This is where you find where objects are remaining stationary or near stationary. So given some criteria, a distance and a duration, which features are dwelling. So this could be where a vehicle is stopped at a light, or you could specify some criteria. Where you are looking for anything that hasn't moved over some duration of time. This is a new tool, which is trace proximity events. So you're finding downstream events that happen within a spatiotemporal proximity of each other. That sounds more complicated than it is. This was actually developed as a COVID-19 use case. So here we have an entity of interest, and I'm going to use the COVID case. This is not all that it applies to, but it's something that we can all understand pretty easily. So let's say that we have person C that has COVID-19. So they are our entity of interest. We specify some distance in time and space that we're interested in finding downstream events. So we could say, let's look for anyone that comes in proximity with 6 meters and within 5 minutes. So in this case, entity C has come into proximity of entity B. And we then see entity B comes in proximity of entity A. And entity C has come in proximity of entity D. This can be applied to a bunch of different applications, but this is the one that came from COVID-19, and I think that helps explain it the most easily. The last new tool that we've added, or One of the tools we've added is Calculate Motion Statistics. This is the second track tool that we added at 2.7, and this one calculates statistics based on the movement of the data. So you give the input points that have a time step, and it's able to calculate things like distance, duration, speed, acceleration, elevation, slope, bearing, and idle statistics. For distance, it can do a min and a max. There's other statistics that are on each of these, but these are the groupings that we calculate. And lastly, these tools don't have to be used in isolation. Something that's really popular is creating a heat map of where assets have traveled. So in this case, we have a hurricane. It's not really an asset, but where something has traveled. We originally had raw points. We put them into tracks, and then we've binned them. This is a lot more informative than just binning the raw points because you can actually see those paths traveled between them. We also have a blog on this one as well. In addition to these track tools, we have other space-time analysis. So we have spatiotemporal joins with join features. We have time stepping, which is used in aggregate points, calculate density, find hotspots, and create space-time cube. And then we also have spatiotemporal clustering in find point clusters. So this is an example of spatiotemporal joins, and it's joining features based on their relationships in time. So we can do joins on spatial relationships, temporal relationships, and attribute relationships. And you can do one of those, two of those together, three of those, any combination that you want. For this example, we're doing a space-time join. So at the top, you can see we have a polygon layer that is an interval in time. So that is that z-axis. And then y, we have points that are an instant. So in this case, we are joining the points that intersect the polygons in both space and time to the polygons. And just to show that you can do it kind of any combination, it does not have to be point and polygons, instants, and intervals. On the bottom, we have the points as our target layer. The polygons are being joined to them, and we end up with points that are intersecting those polygons. Again, there's many different relationships here. You know, it doesn't have to be intersect. It can be near distance. It can be contains, touches. There's a whole bunch of them, and as well as a whole bunch of different relationships for time as well. Time stepping allows you to analyze your data at specified intervals. So you can specify the duration, how often you do it, and how to align it. So for example, you could say, I want to analyze my data hourly. So you'll get aggregated points that are hourly. Or you could do something more complex, like I want to see just a slice of time, which could be every Monday starting at the start of the year. And lastly, we have spatiotemporal clustering, which allows you to find clusters of points based on a minimum number of features in a cluster. So you could say, you know, this cluster has to have 10 features to start forming a cluster, a distance, and a time distance. So here, I believe we have a bunch of Uber pickup locations in New York City. That's the purple. And then when we've clustered it by both space and time, because a lot of these points are probably stacked on each other, they could be at completely different times, we're able to see clusters of pickups that represented conferences at the Jacob Javits Center. So with that, Bethany is going to give us a demo of track analysis.
Thank you, Sarah. So now I'm going to show you two ways that you can enrich your movement data using GeoAnalytics. Then a quick demo of how you can use that enriched data in further analysis. So the first way that you can enrich your movement data is using one of our track-aware tools and arcade expressions. In this example, I'm going to use these 3 million AIS ship locations near the Alaskan Islands and the tool Calculate Field. I'm going to enrich my data with speed information. To do this, I'm going to calculate a new field using the arcade expression track current speed. This is going to result in a new field that contains values of speed for each GPS location in my dataset. This is a quick way to calculate the movement statistic of interest. But another workflow to calculate multiple motion statistics for your data is with the GeoAnalytics new tool called Calculate Motion Statistics. With this tool, you can select one or more groups of motion statistics to calculate for your dataset. In this example, I chose speed and acceleration. This is going to result in multiple new fields containing speed and acceleration values for every location in my AIS ship dataset. Much like the result of Calculate Field, all of these statistics are ready to be used in further analysis so you can better understand the patterns and emerging trends in your shipping vessels. So that's a couple ways to enrich your data, but let's take a look at a way that we can use this enriched data in further analysis. I'm going to use the tool Reconstruct Tracks. At 2.7, this tool offers the ability to split your tracks using arcade expressions. So using these AIS ship locations near Florida and the Bahamas, I'm going to split my tracks at locations where the ship's current speed changes by greater than 2 nautical miles an hour based on the last speed. With this result, we've symbolized the movement data so that we can understand where the ship's speed is exceeding 8 knots per hour. This is a speed that's known and likely to disrupt ecosystems in coastal areas. Quickly, another popular enhancement for Reconstruct Tracks is the ability to specify how your tracks are handled. For example, as you would likely expect, the results from our previous analysis are continuous lines. However, prior to this release, we would have created a track with a gap at the split location, something like you see here. But with the new split parameter, you can specify how to connect the tracks for a more intuitive and visually pleasing result. So with that, we've seen how we can enrich our movement data and how we can use it in further analysis so that we can understand the trends in our data. Now I'll hand it back to Sarah. Thank you.
Thank you, Beth. The next thing we want to talk about are big data connections. Big data connections read directly from collections of data sets in a directory. So these can be delimited files like CSVs, tab delimited files, shapefiles, Parquet, or ORC files. These are so powerful, and we kind of put them in the 2.6 release, and I think that a lot of people can get a lot of value from this. You do not need to have big data, and I think this is something that if you took one thing away from this session, it would be to check these out, especially if you've had trouble loading things into ArcGIS before. So you've been doing like an event table or, trying to import your CSV. This will make your lives a lot easier. So I'm going to talk about a few examples of when you can use big data connections. So you can represent multiple data sets of the same schema and file type as a single data set. So looking back on this earlier slide, on the right I have Lightning. So I have a single folder called Lightning, and then I have 12 shapefiles within it. When I register a big data connection, it's going to create a data set called Lightning, and all of those shapefiles are going to be used as a single data set when I run analysis. So it's not just going to use Lightning 01 2015 as an input. It's going to use Lightning 01 2015 all the way down to Lightning 12 2015, and all of that will be analyzed at one time. When you actually register them, on the left you can see we've registered a file called demo BDC. Every folder below that you register is actually a data set itself. So you can see that we have Lightning listed there, and then Lightning contains all of that data. We do this structure so that you have so much flexibility under that top level folder. So you register a location of folders, each folder represents a data set, and then what you have within that data set folder just has to have the same schema. It doesn't have to be, you don't have to have the same names. You don't have to name it as nicely as Lightning 1 2015. It could be Lightning, Thunder, whatever you want to name it. It could have a bunch of folders underneath. As long as it's the same schema, all of that data will be read for analysis. So the second example is a BDC accesses the data when the analysis is run, so you can continue to add data to an existing data set in your BDC without re-registering or publishing your data. So going back to this previous example of Lightning, so right now this is a bit out of date, right? It's 2015. So I've registered this, I've run analysis on it, and it used all of these data sets from 2015. If I suddenly got a whole bunch of data from 2016, 2017, 2018, 2019, 2020, maybe a few months of 2021, I could throw that in the folder, and the next time I run analysis, it's going to pick up every single data set. There's nothing additional that you have to do once you've registered that Lightning file. This means that if you have data coming in all of the time, it will just run the analysis with whatever is there. There's no extra steps or merging of your data sets, which I know can be quite a pain sometimes. The next reason you might want to use BDCs is you can modify the BDC to remove, add, or update which datasets are visible. So that is nice that, if you have all of these datasets listed, you have all of these folders, you don't have to actually see all of those. You can just hide them and only have Lightning if that's the only one you're interested in using. And lastly, and I think this one is really important, it's really flexible how time and geometry can be defined, and you can use multiple time formats on a single data set. I know that the Hurricanes data set that I use for a lot of demos and examples actually has two different time formats. So it has a field that does something like, year, day, month at a time format, and then it also just switches halfway through to another format. You don't have to go and reformat this data set. You can just register both fields or both format types, and it will fail over if needed. It also means you could have time across multiple fields. Maybe you have one field for hour, maybe you have one field for day, one field for month, year. All of those fields can be used in conjunction to create time with just how you register the data set. So it's very, very flexible and powerful for registering time, and then you can also do the same for geometry. So to actually create a big data connection, we have 7 tools. You do not always need to use all of these. These are basically utilities to modify and arrange the big data connection that you need. You do need to create the big data connection. That is one required tool. But other than that, that's the only one that's required. The rest allow you to copy them or duplicate, preview, refresh, remove, or update. Update is how you would modify the time and geometry format. So that one's probably another one that you should be looking at if you're using these. When you actually register them, so this is a big data connection that's been created. The image on the right, we've created a big data connection called mybigdataconnectionfile.bdc. That will show up in whatever folder you've said you wanted that BDC file to be, and it will list the data sets there. So you can see that I have AIS ship locations. It's a point feature layer, it's a point data set. So if I added it to the map, it would draw points. It's called _CSV because that's the underlying data type. That's just there for our naming. It does not need to be there. But you can see that I have data sets based off shapefiles, ORC files, Parquet. I have tables. You can do lines and polygons as well. You can specify them by well-known text or well-known binary strings. So there's a whole bunch of different formats and flexibility here with big data connections. And to show you that, Beth is going to give you a demo of connecting to your big data using a big data connection.
Thank you, Sarah. Big data connections are a new and incredibly valuable data source for ArcGIS Pro analysts. Working with desktop data, we're always looking for ways to make it easier to get our data into ArcGIS. And that's exactly what big data connections offer you. So today I'm going to showcase how you can create your big data connection, or BDC as I'm going to refer to it as, and also how you can use your BDC datasets in your common everyday workflows in ArcGIS Pro. All right, to get started, let's take a look at the source folder I'm going to register as my big data connection. Here in my folder, big data _ source, you can see I have 3 subfolders. In my big data connection, each of these subfolders are going to be registered as their own dataset. But what's interesting is that each of these datasets are structured completely different. You can see that my fire incidents are stored in 2 separate subfolders that each have their own shapefile. But because both of these shapefiles have the same schema, they're going to be registered as a big data connection dataset called fire incidents _ SHP. Perhaps more commonly, we have a folder of CSV files. These are hurricane incidents that were collected over 4 months, and they all contain the same schema. And these will be used as a single dataset called hurricanes _ CSV. I'll also note that we do support some less common GIS data formats like ORC and Parquet. But now that we've seen the source data, let's go ahead and take a look at how we would register this as a big data connection in ArcGIS Pro. So first I'm going to navigate to my tool, Create Big Data Connection. All I need to give this tool is an output location to store the big data connection file, the name of the file, and the source folder, which is the location I was just showing you in File Explorer. While this is running, GeoAnalytics is sampling my datasets and making its best guess to determine properties like time and geometry. For example, if you have CSV files with fields named lat and long, or x and y, GeoAnalytics would assign those fields as the geometry for the dataset. Similarly, if you have a field called datetime or myDate, we would parse it for the format and set that as the dataset's time property. All right, so you can see that my big data connection was added to my catalog and my 3 datasets are now available. You can go ahead and add these datasets to a map if you'd like, but I'm going to use my ozone measurements dataset in a notebook in ArcGIS Pro to detect ozone anomalies using the GeoAnalytics Desktop tool Detect Incidents. This tool is going to search along individual ozone sensors for readings that meet a certain condition. Here you can see that the input data contains 55 million sensor readings, and these readings were collected at over 300 different locations across the United States. Although in my map this data doesn't look very dense, you can see that at just one location there are over 14,000 records. GeoAnalytics is going to search along the records for each location using a track ID, and it's going to detect anomalies in my track data that meet a certain condition. So all I have to do is give the path to my big data connection dataset, give the track field, which is the site number for the sensor readings, and a condition. So this condition says that when the average sample measurement over the last 8 hours is greater than 70 parts per billion, we'll return that feature as an incident. This tells me that this location reached a certain level that I'm going to consider dangerous or something that we should look into further. And the result of your analysis is going to be a time-enabled data set that you can visualize as a heat map so you can detect anomalous trends in ozone readings over time. This is useful insight so that you can go ahead and apply these findings to your process to mitigate or avoid future incidents. So with that, we've seen how GeoAnalytics is able to crunch through sensor locations with tens of thousands of records using tracks so we can uncover anomalies or problematic trends within your datasets.
Thank you, Bethany. So that was a demo of how you can connect to your big data and use big data connections to do that and then run analysis on it. Now I want to talk about some considerations when running GeoAnalytics desktop tools. So there's a few things you need to know about running these tools. So I've already mentioned they're based off of Spark. So there's going to be some things that are required knowledge about how Spark runs and how we can manage the amount of cores and memory used. So GeoAnalytics tools use Spark, and by default it uses 95% of the memory on your machines and all of the cores. So here on the right, you can see all of the cores I have on this huge machine. This is not a realistic machine. We do not expect you to have 36 processors on anything you're running analysis. But when I run a tool, you can see that the analysis is distributed across all of those cores. Usually we are running with 4 or maybe 8 core machines. I think we maybe have a few machines on our team for testing that are bigger, but your 16 or 32 gig machine with 4 or 8 cores is perfectly reasonable. You can use the parallel processing factor to control the core usage. And then something that's really important to know is that there is a startup time to start Spark. So GeoAnalytics tools are not going to always be faster than a comparable desktop tool. So let's say that you wanted to run buffer on something. There is already a buffer tool in the, I believe, analysis toolbox. And then there's also the create buffers tool in the GeoAnalytics toolbox. If you were to go buffer 100 points, the GeoAnalytics tool would not be faster, like absolutely would not be faster. If you were to go buffer a few million or more, that's when you might seem to see more gains. There is no standard number for each tool to say, this is the cutoff of when it has become more performant. If your workflows are already working for most tools, you can stay there unless there's a feature in the GeoAnalytics tools you want to start using. But if you wanted to start using something like reconstruct tracks, that's only available for GeoAnalytics. So if you had 100 features, reasonable to use the tool. There's no comparison for a tool already in desktop. So what this means is that when a tool starts, it's going to take about 5 to 15 seconds to start up Spark. So any tool that you're running that already takes less than 15 seconds, the GeoAnalytics tool will definitely not be faster. But that's just something to think about. When you run multiple GeoAnalytics tools back to back, there might not be a startup cost for the second tool because the startup will happen, the tool will run, and before that Spark session times out, then the next tool will be started and it will already continue to use that same Spark session. These are a different implementation of tools. So it's not like we just took the code for that buffer tool and put it and we're like, great, now it's running on Spark. We had to redo everything from the ground up. So all of the developers are working on how we can implement parallel algorithms that work on your machine. So in some cases, the results won't be exactly the same, or there might be slightly different functionality. So an example is this is a result of, I think, create buffers again. So the orange is the GeoAnalytics result and the blue is the normal buffers tool. You can see that in this case, we have fewer points representing the circle, and that's just something that we do to make the parallel processing faster. So that's an example of something that you can visually see, but you might see slight differences in other tools as well, especially with slivers. So one question I get a lot is, how fast will it be? You know, I have this tool. Is it going to be fast? What do I need to do? And there's a lot of things that account for differences. Going back to our favorite tool, buffers, I think is just one that everyone's familiar with, so I get stuck on it. It's like, if you just ask me how fast buffers will be, not the GeoAnalytics one, just the normal tool, I think you would all know, like, hey, there's different things I would consider. Buffer is going to be much faster for one feature than it would be for 2 million features. So we know that there's different things. It will be faster for points than it would be for the same number of polygons, for example. So the performance of the GeoAnalytics desktop tools depends on multiple factors. So I've kind of grouped them into 4 sections: your input data, your data sources, your tools and parameters, as well as your hardware. As much as possible in the documentation for the tools, we try and give you suggestions for how you can speed up performance if that's what you're most interested in. So it might say something like, use this parameter instead of this parameter. These are the trade-offs. So for the input data, the number of features, the geometry type, and the number of vertices are going to make a big difference. In most cases, like a point will be much faster than lines and polygons. And then obviously fewer inputs. You can limit the inputs by setting an extent or applying a filter, and so I would recommend that if you can. For geometry type, points faster than polygons, lines points faster again, and the number of vertices. If you have a really, really complex polygon, GeoAnalytics is not the solution for doing analysis on one huge polygon with a lot of vertices. That's definitely not the target of these tools, so I wouldn't recommend applying GeoAnalytics to that if you think that it's something that's slow because there's too many vertices. GeoAnalytics won't help there. For data sources, colocation and file type. So for colocation, if you had your big data connection on the machine that you were running Pro on, it's going to be a lot faster than if you had it somewhere on a slow network share, for example. And then also like an enterprise geodatabase, those can be a bit slower than something like a shapefile, for example, which kind of leads me into file type. Big data connections are really fast in GeoAnalytics tools, especially we find that Parquet files are. So one thing we say is people ask if they should convert their data. We don't want you to do that. The time of you converting your your shapefile to Parquet probably isn't worth it. We like you to use the data that's already in the format in. We're trying to cut down on that data prep time. But Parquet files, ORC, delimited files are all pretty quick, much faster than, say, shapefile or file GDB, and then enterprise geodatabase is usually the slowest. For tools and parameters, this is the one that we try and help with documentation the most because it's the one that we kind of specialize in and we have an idea and are able to test out a bunch of different ones. So the operations being used, maybe planar versus geodesic. In many cases, if you can get away with planar, if you already have a local projection, then do that. Geodesic is more time consuming. It's also something where maybe you want to prototype stuff out and you want to use those fast parameters, and then when you're ready for the final result, maybe you can use the parameters that might take longer but get you the best result. Something like the number of neighbors. So calculate density versus aggregate points. Calculate density creates a neighborhood relationship, and then the more neighbors that you're doing, the more the calculation or the longer the calculation will take. Whereas aggregate points does something very similar visually to calculate density, but doesn't actually have to calculate those neighbors. So in some cases, there might be another tool that we would recommend depending on your use case. And then being able to distribute the data. So again, we try and document it that we have parameters that will help distribute the data better. We don't want you to have some in-depth knowledge about Spark, like you definitely don't need to, but there are parameters out there, especially with track parameters, to split up your tracks that will distribute the data better across your cores and perform better. And then lastly, we have hardware. So the amount of RAM on your machine definitely helps. I believe on the next slide, I'll talk about this a bit more. The drive space and speed can also help, like improving your drive speed is definitely beneficial. A solid state hard drive performs really well. And then cores as well. So I had that other slide, I think, where I had 36 cores. That is not expected, but a machine with more cores and more RAM is definitely going to perform a lot better than one with less. So some details on the RAM. So Spark uses memory to run analysis. So all of that processing is in memory unless it runs out of memory and then it will spill to disk. So if possible, usually the first thing we recommend to increase is the RAM. So I would not go and say like, oh yeah, go get more cores first. I would definitely say increase the RAM if possible. Like the jump from 16 gigs to 32 gigs is amazing in some analysis. Sometimes, something will barely complete in 16 and then it can take, a few minutes with 32 gigs or a few seconds with 64. So we do see a lot of improvements there with just the memory. And then if the job can't be completed, it will spill to disk. So you do want decent disk space. It uses your temp drive. So that's usually in C somewhere. You can change your temp drive to another location and it will use that. So we found that is helpful sometimes. And that's just a Windows setting. It's not a Pro setting. I was able to figure it out by Googling. In the documentation, we now say how to do it and point you to the right resources, but that is something that you can do on your own and it will improve the performance as well if you're running out of space and memory. But in that case, it's like if you could also increase your memory, that would be much better. And then, so what if you need to run on even bigger data? So say those machines, you have a machine and it's running on one and it's still not performing as quickly as you want, or it's not completing still because, there's just some cases where the data is so large, the computation is so large, it can't be completed on one machine. And in that case, that's when we would recommend something like GeoAnalytics Server. So you can distribute it across multiple server cores and machines. So instead of just a single machine, you could have 3 machines. It can use a spatiotemporal data store, and you can have larger results with server instead of using desktop. So with that, for our summary, I wanted to talk about how GeoAnalytics is accelerated. So it's speeding up analytical processing time using built-in parallel compute. So Spark is available in all those tools. It's being used for all of the analysis, and it's just automatically parallelizing the analysis on your machine. The tools are spatio and temporal. So most of the tools are designed for analysis with space and time. There are some tools that are just tabular. There are some tools where you don't need space or you don't need time, but we really do want to emphasize that for a lot of people, it will be some kind of track data, and space and time are both very important. It's integrated to work in Pro with your data in ArcGIS Pro. So you have whatever data you have there. You have, a bunch of CSVs that you've got from logs somewhere, or you're using shapefiles. It works with that data quickly and is able to write back out to those shapefiles or file databases. And lastly, it's actionable. So you can crunch through large volumes of data to generate actionable insights and intelligence. And I'm sure you saw that with some of Beth's demos. This enables you and your organizations to visualize and react to large amounts of data in a clearer and more meaningful way. I have some helpful links here. If you need anything, please feel free to reach out to us at geoanalytics-PEs@esri.com, PEs being product engineers. We probably have some additional resources, or we can help you assess if you're doing something wrong with the tool, if there's a workflow that you don't understand what to do, we can help you through all of that. Your feedback is really important to us because it helps us decide what's new tools or new features do we need to add, or if there's something that people are reporting isn't working as well as they expected, we can prioritize that as well. So we really do appreciate that feedback, and your questions are something that helps us gather that feedback. So thank you very much. We're sorry we're not in person this year, and we hope we can be next year, but I hope you enjoy the rest of Dev Summit 2021. If you do get the chance, please provide your feedback in this survey. We've done the session for 2 years, so if we're finding that people are coming back and seeing the same thing and want new information or something else that we can share, we'd love to hear that as well. Or if you really enjoyed it, we also like to hear that. So thank you so much.